Hey everybody, this is Larry. This is day 30th of the May Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Divide two integers, what? Uh, okay, so given two integers, dividend and divisor, divide two integers without using multiplication, division, and mod operator. Okay. Uh, hmm. Without using multiplication, okay. Numbers can be very big. Huh. Not gonna lie, I don't know how to do this one. I mean, without multiplication is a little bit weird. Because at least, the way that I would have done it is doing some sort of like repeat multiplication. Or another thing that you can do if you really like is like binary search or something, right? But that still requires multiplication. Maybe is there some weird thing that maybe this is the type of problem that I'm not quite used to doing. I mean, the other thing you can do is like repeat adding or something, right? But there's no guarantee that it'll be fast enough. So, well, I'm trying to think like what are they trying to ask for, you know? And also whether like like shifting, like binary search but with shifting instead. I don't know. That's very silly if you ask me. But yeah, I don't know this one. Have I done this one before? I've done this before. What did I do before? I really okay. I just got lazy last time. Yeah, this is a waste. I don't know. I'm trying to think. Honestly, this is one of those problems where like I'm trying to like right now read a little bit in the intent of like what to learn or like what is the learning process, what is the intended solution, and like if someone is asking me this on an interview, what am I trying to get out of it, right? And I think right now what I'm trying to get, what I feel is just that this is a troll question, unless I'm missing something really obvious. Uh, yeah, and or something that I don't know, like if you could do bitwise shifts or something, right? Does that count? I don't know. Let's see. Yeah, or something that only works with certain like input sets that are not great. Um, yeah, yeah, I don't know. Not gonna lie, this is just a way. Like, is it really supposed to be just like a almost like a not binary search, but I don't know. But I've always maintained that bit shift type situations are almost kind of like you're still doing division. You just uh, I don't know. Let me see. All right, let me try to think. Let me do it on paper a little bit about okay, like I guess the way that we can think about it. Well, one is just normalize these to let's just assume that for the without loss of generality, pretend that they're both positive, right? Then now we can think of this as a base. Um, yeah, you can think about it as a base, but I was gonna say base divisor number, but I and then maybe you could do binary search uh, with bit shifts or something like that. Because basically you can do the bits one at a time. Eh, this is such a silly problem, though, if you ask me. I'm just trying to think. Yeah, I mean, there are ways to do it, right? And you could do a shift. Uh, yeah. Okay. I mean, all right. Let's just say positive is equal to true. Uh, if dividend less than 0 is not equal to, or if something like that, right? This is a very silly problem. I don't know if I really want to invest that much time in it, to be honest. Is that true? Yeah, I think that's roughly right. Because yeah, if the signs are the same, then the positive, right? And then if dividend is less than divisor, then we can just return 0, right? Oh well, we have to convert it. Okay. So then now, what do we do? Mm, uh, uh, okay. I guess we have to try to think about a bit at a time, right? Um, yeah, let's say we're given shifts. I guess you could also pretend a shift is just a number adding itself, so maybe that's fine. Um, and then the idea is that okay, so in a binary way, let's say you start with multiple of 1. I'm just checking the MBA score. Okay. And then we check to see whether 1 is big enough, and then 10 is big enough, and then 100 is, or this is in binary, sorry. So this is actually 4, and then 8, and then 16, and then just take one bit at a time. This is very silly. Um, yeah, I mean, I think there's probably a more clever way, but I think doing this is like n squared, where n is the number of bits, should be fast enough. So let's do it that way. Okay. Yeah. So let's just say, uh, Okay, let's say we have an answer is equal to 0. We return an answer at the end, and then let's say we okay. So then now we have this, right? And then the idea here is, while left is greater than 0, left, we basically want one iteration of getting the biggest number that fits left. What is it called? I'm trying to think of a variable name that's reasonable, but I am blanking out, so I just call it B for now. And then this is fine. Let's just say left divisor, right? And that's pretty much it. And of course, pretty much it except for the function left to right, obviously. Left and divisor. I guess the divisor actually doesn't change, but nonetheless, it's too late. And then here, the idea is that we have a function that let us find return two things. The remainder and the multiple that is a power of 2. Does that kind of make sense? Meaning that the remainder and a number b such that b times divisor is less than such that b is the biggest power of 2, biggest number that is a power of 2. Is that in such that? Okay, right? I think that's basically what I want to do. And then basically the idea here is just taking one bit at a time. Oh, and I forgot to do this bit. And also this is wrong in that we have to do like a few more things, but I think this is a good start. So basically, for example, we have to convert it back. If positive, then return answer, else return negative answer. And maybe we have to do some, I don't know how we have to do this other thing, but this is such an awkward part, but I guess that's okay. Yeah, okay. Sorry, I just keep on checking on the NBA game. This is game 7 today. I just skipped the vlog, but at this very moment that I'm recording, the Heat is down 15 points if you care. I don't know, maybe you do. But I'm rooting for the Heat because Jimmy Butler is kind of, it's been playing very well, and we'll see. Well, I'm not watching the game, so let's finish this as soon as possible, and then we'll go back to it. Okay, so now that we can say that, then now we go, I don't know if they allow power per se, because you can't do multiplication, so I cannot just do like, yeah. So then the idea here is that, we just want to do, try with divisor times 2, divisor times 1 is big enough, times 2 is big enough, times 4, ... And the way that we can do this is by shifting, I guess. The two ways you can do it, shifting or current is equal to divisor. Yeah. Right. And then we have to keep track of the B, I guess. I keep going. I don't know. I don't know the name for these things, so just say 1. And then now, while current is plus current is less than left, something like that maybe, because it's current times 2. Maybe Leetcode too. Yeah, okay. Then here we do current, current, this is basically times 2, right? And then B also times 2. And that's pretty much it. And then at the very end, we return left minus current and B. I think this is the right idea. Maybe I have some off by ones, but let's give it a spin. And of course, this problem is easy to test for in the sense that maybe I'm off by one, but it's easy to test for in the sense that you can make up any case and you know the answer, like 200 over 20, 300 over 1 or something, right? Let's see if I'm always off by 1. Maybe I am just always off by 1. Let's see. Oh, I mean the last 2 is right. So why do I have this wrong? What was it? 10 divided by 3. I put 4. So 3, 6. So 6 should give you a 2. Okay. And now you have 4 left. Okay. Let's also just print it out real quick. Left minus 1 B. But I can see why I got downloaded. I'm not a big fan of this problem because there's just a lot of weirdness that you don't really. I guess maybe it's, I don't know. I don't know how I feel about this, but yeah. 10, 3, yeah, 6 makes sense because now there's 2 in the answer, and now 4 is 3, right? And then 4 now, and then okay. So left minus current. So we have an extra 1. That's why. Because left is greater than 0. Okay. I guess we want to round down. So then what happens, right? So actually, if it's left is greater than, you go to not current, but divisor maybe. Because if it's smaller, then that should be okay. Or rather, that should be okay. Now I have to think about the overflow case, just because that's a core part of this problem. Okay, I have to use the calculator app to 2 to the 31. Okay. So we have negative this number, and then just 1, say. How do you get a number that's strictly less than? Just by division. I guess like, I guess you have something like this over -1 or something. Let's see. I think that's fine. Oh, I thought I would get that well. Or I think the other way maybe. I should have kept the other one. Yeah, I mean, but that's just like an off by 1. That's fine. That is the magical power of using Python, is that I can test this without. I mean, you could just use long anyway, I suppose, if you use another language, and then you'll be like, oh, this is off by whatever. Which one am I wrong by? Okay, so it's I go over the max. So okay, I mean, I think I'm just gonna cheat a little bit. And saying if it's positive, it has to be this or something like that. And then here we have to do max of this or -1 over 1. And you should read up on 2's complement in general. But I'm a little bit lazy, so let's give it a spin and see if this is fast enough. Apparently I did this, I don't, what's this, a year ago now? But I was a little bit lazy. I wonder how I don't know. I don't know if there's a video on there, but maybe it's not that useful. 790-day streak, so yay. Let me know what you think. Yeah, complexity, sorry. That was a annoying one, right? It took me 20 minutes. But yeah, but basically this loop, right? How many loops are there? Well, every time that you loop here, you take the biggest power of 2 number. So at the worst case, let's say you have a 32-bit number. This is going to take the first time it's going to be moved like from the answer. Let's say the answer is 2 to the 31 or 2 to the 32, right? If the answer is 2 to the 32, then the first run it'll take 32 times, and then it'll take 31 times, and then take 30 times, right? So so this is going to have at most 32 loops, right? So this is let's say r is equal to the number of bits in the answer, which is dividend. So this is going to be all of r loops. Of course, just to be clear, log r is equal to log of input is equal to r. So log of n, if you want to call it that, is equal to r. So all of r loops, and each of this takes all of r loops again, right? So this is also O of r. So this is effectively total time is going to be O of r squared, or maybe if you want where r is the size of the input, right? That's why I use r instead of r being range, is why I said it that way. But maybe that's an awkward notation. But because the input is the number of bits, of course, if you want to say that the n, like if you want to say this is n, then this is going to be O of log square n. Same idea, right? Yeah, in terms of space, depending on how you want to say it, because we do use variables here and here. That said, each of these variables is the size of the input, right? So this is going to be linear. Total space is equal to linear, right? Because each of these variables is the size of your input, right? In fact, we, using like 5 ints, it probably is even, it takes more that way. But yeah, so I'm gonna say that or something like that. But yeah, in fact, we use more space than the input. So that's pretty much all I have for this one. It's I don't know. It's a little bit weird. It's a little bit messy, and apparently it's a little bit slow. But yeah, I mean, I think once I came onto this solution, maybe I'm a little bit happy about it. But it's still obviously way way awkward, and I don't know how I feel about it. Anyway, that's all I have for this one. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.